Good morning, good afternoon, good evening, wherever you might be. While many of you in the European time zone might be debating whether to have a sandwich or a salad for lunch, here in Kuala Lumpur, I'm caught in a dilemma to grab an early dinner or a refreshing cocktail to enjoy the night skyline. I'm not sure if you know what I most likely will do. But yeah, a little glimpse into how interconnected yet diverse our world is, and a reminder of how innovations like Metaverse bridge these delightful gaps. So today, we are about to traverse the boundaries between the physical and digital realms as we delve into the fascinating world of the industrial metaverse. To shed light on the transformative frontier, I'm thrilled to present our collaboration with ZF. And together we are navigating the uncharted territory, these kind of uncharted territories of industrial metaverse. So my name is Christian Klessner, and I'm the CTO of Hololux, a leading innovation agency from Germany. And I guide some of the most vibrant brands on their journey into the metaverse, helping them to achieve more by harnessing latest technologies. But my passion started early for IT. My parents had a travel agency in Germany and they invested in IT early on. I can still remember very well when, as a child, I stared for hours into the amber sparkling screen of an IBM AS400 and the promising cursor. Ready. The tabula rasa, the chance to create something completely new out of nothing. It's still what drives my passion into IT industries and software development. And with the emergence of the metaverse, my childhood dream has come much closer to reality than ever before. I'm also proud that my engagement in this field was awarded with the Microsoft MVP award for the 14th time in a row. So I bet most of you know what the MVP award is, but I always call it kind of the Oscar from Microsoft. But today I'm not alone. I'm very happy to be here together with Tim.
Yes, thank you very much for having me here today. My name is Tim Brunkel. I'm X-Reality Program Lead at ZF Friedrichshafen. Just a few words about ZF. We are a global technology company in Germany and actually one of the biggest suppliers for passenger cars, commercial vehicles, and also industry technology. About our size, we are about 160,000 employees, so and 40 billion annual revenue. So you can imagine that we are working here with enterprise requirements. We have 168 production locations, and they are really a big part of our X-Reality activities. So what we do is we create AR and VR solutions for training, maintenance, remote assistance, and so on, and also with the latest and greatest technology. And in order that we further digitize our production facilities, that's why we have started the collaboration with Hololux on the topic of industrial metaverse. And therefore, we would like to show you a 3-minute video that is exactly explaining what we do and how it already looks like, and you'll get some information. Have fun watching it. Right. Yeah, so I hope you enjoyed this one, and therefore that is just not a marketing video. I'd like to also show you our proof of concept here that is allowed to share. I'm sharing here, so assuming you can see my screen. We have an browser-based environment. This is initially one of our big limitations. Of course, not everyone is owning a big VR workstation or having an intensive GPU-powered device. That's why we have something that everyone can access. Yeah? And actually, what we have here is our washing machine, or it's our grinding machine. Sorry. Connected to real-time data from the production floor. We have different views, yeah, and if I click on the different assets within this machine, I'm also getting the real-time information. So let's, for example, here we have an issue with our x-axles. There might be some value not really perfect, and I can directly see that and react on it as a production worker. Not just that, we also have avatar integration, means if there would be a colleague or anyone else right now within the same environment, I can see where they are, where they stand, what machine they are at the moment looking at. So, for example, if I have a warning or an error message or anything coming up, I definitely directly will see that in that environment and can react based on that. Different views, different dashboards. And probably one of the biggest challenges is definitely to bring in the real-time data, but more about it later. One big goal, of course, is to have this for all our production facilities, but also use such environments to do benchmarks. For example, I put in all our grinding machines, then I can see why is, or I configure my own environment, and then I can directly see why is the machine in India producing 2 parts more per day, per shift than the other machine, and then work on those optimizations and so on. So there are different scenarios. But actually, this is one of our environments where you then get a feeling of how that looks like. Yeah, some usability features then, of course, will be then the whole sharing your screen, also connecting it to HoloLens, for example, to directly get in real-time connected to the on-site shop floor and so on. There are a few plans and few actions also that will then happen and be ready to show soon. All right.
Should we go back to the presentation, Tim?
Yeah.
Okay, wait a second.
Yeah.
So I jump to the right slide, takes a second.
There we go. Yeah, big question is always the why. Why do we do that? Yeah, I mean, there must be a benefit, and that's why we tackle at the moment 4 main use cases with this technology. Live data visualization, I mean, yeah, just as an example, today we are very data-driven in our industry, and we need the ability to visualize, and understand those real-time data, and this can be really a game changer. So, yeah, again, the days of the normal static charts, and no one wants to see just the Excel file anymore. So the Industrial Metaverse here transforms this by offering us this live and immersive. So the whole 3D data visualization will be, not just more interesting, it will be a different experience, and I can also understand the data way better. Yeah. So just imagine that you're stepping into this digital replica of the factory, and then you're seeing the real-time data streams, or you can see also the vibrant graphics and something like this. This is just a big difference. Yeah, we're not just talking about aesthetical pleasing. At the end, it should also be a faster decision making. Then the next use case is virtual layout planning. At the moment, we're doing this, for example, as well with HoloLenses. We're using holographics, and we're placing them, and we can already do some collision warnings and everything. But here with this virtual environment, we can set up or reconfigure the plant or the factory layout completely virtual in this web-based application, and this is a massive investment of time and money and resources that we can save here. Yeah. With the Industrial Metaverse, now we can also create and test and also modify then the entire plant, and also make those decisions, send them to our management for approvals and whatever. So this is everything what we then can do in this kind of sandbox. Yeah. Yeah, then the third important use case is that we can train and enhance the skill of our employees. So training in the industry, especially those with the complex machinery, this is sometimes a high risk. For example, we have already implemented high voltage training completely virtual, and you can do that without any risk, because if you touch those high voltage part in real life, you'll be immediately dead. Yeah, and there you can train it as often as you want, many times you want. You can scale it. Yeah, and this is a big benefit of such environments. And yeah, at the end, we reduce onboarding times, we improve the safety compliance, and many things in this direction. Yeah, and last but not least, simulation-driven process optimization. Yeah, of course, every industry aims for optimization and to get the most of our resources at the end, and to reduce waste and increase the efficiency. We have solutions like this. Yeah. Now we can run countless simulations, yeah, to refine the process. And just to give you here an example as well, I mean, you've read it probably also in the news, BMW, how they are using this technology together with NVIDIA. They already simulate their whole factories 1 year before it's being built. Yeah, at least what you can read from the official sources. And this is definitely a big game changer for the whole factory planning. Yeah. But of course, we can only do that when we have a strong technical base, and therefore it all starts actually with the data that we show. Yeah, first of all, there's the data, so to say. So where does it come from? ZF has started an initiative called Digital Manufacturing Platform, or in short, it's the DMP. This is a strategic project in CFIT, where there's also Microsoft involved, with the goal at the end to connect all machines in our production locations, and with high-end technology on Azure infrastructure. At the end, we collect those data and make it usable. Yeah, the data then at the end can be dashboarded, or we use different APIs and make that available for third-party applications such as Industrial Metaverse, Omniverse, and so on. Yeah. Of course, but more about that later. Data is a very highly confidential intellectual property of CF. Those especially those operation processes. That's why there are also intensive security mechanisms to protect our data, which make it maybe sometimes a bit harder to access. But I think that's one of our challenges.
Yeah, so after Tim has explained the DMP side, let's delve into how it integrates seamlessly with Azure Digital Twins. So Azure Digital Twins act as an interface between DMP, IoT, and our mixed reality client. So picture this: whenever a digital twin undergoes an update, Azure's event grid is immediately triggered. And this sets off a chain reaction. An Azure function listening in the background springs into action. This function essentially acts as kind of a dual conduit, an API facade on one end and an event broker on the other, directly communicating with our mixed reality client. So now imagine the client receiving this update in real time. As the event gets fired, our Azure function dispatches a signal R message straight into our mixed reality client. But the really cool thing is, our client, like Tim already mentioned, is not just restricted to a niche audience. So we made it universally accessible through a web client. And for those seeking more immersive experience, MetaQuest is our tool of choice. And so we also have a Quest client for this application. So from a technological standpoint, we've incorporated the good old famous mixed reality toolkit, or short MRTK, for building that application. And as Tim already mentioned, and for sure ensuring a robust security is important, but Azure AD has us covered for this. To elevate this to a multi-user experience, to make it more metaverse-like, we've leveraged photon networking. And yeah, in summary, this integration provides a fluid, interconnected experience in the realm of industrial metaverse, acting for us as a little bit of a blueprint and pattern how we can use that for other applications. So did we face challenges? You can bet we did. So first, for example, technical complexity. One of the hardest challenges stemmed from inclusive web clients, a low-end business hardware. Beyond the optimization of 3D models, many Unity plugins does not support web clients. So everybody who built with Unity and try to build web clients will know what I'm talking about. So a web client is a very, very hard to build. But the challenges began even before this technicalities. The question was, how do we collaborate with the ZF team and the DMP experts? Because I have no clue about DMP, and it's as you can imagine, it's a huge project and it's quite complicated. And as Brively mentioned, we utilized Azure Digital Twins as an interface, so ensuring that we didn't need an in-depth knowledge of DMP. The Azure Digital Twin was our common ground where we exchanged the data. So moreover, communication between engineering, that's more on the social side, and IT in general was not without hurdles. The engineering teams knows their machines inside out, but lacks familiarity with immersive technologies, and vice versa. We don't have a clue about all their machines and what data they collect and what it's actually about. Additionally, they often, for sure, use also 3D formats, but other formats than we usually use. They use CAD formats like STEP. And this required also the establishment of a conversation and optimization pipeline to make it actually ready for the web client. And we were even happy when we got 3D files at all. This is not that you get them all the times from your vendors. So the challenges didn't stop there. We also grappled with challenges like data security and privacy. But Tim, what do you tell a little bit about that?
Yeah, like said, operational processes, they are a big part of intellectual property and they must be protected at any cost. Yeah. So of course, the Industrial Metaverse offers us unmatched collaboration and real-time insights, but in the same time, this means that we present potential vulnerabilities or threats that could expose those sensitive data, for example, for espionage or sabotage. And this is actually our main risk here. Yeah. Means, we embrace Industrial Metaverse promise and then we prioritize this. And of course, everything that has been developed has been under the question, is this secure? Will this be accessible from outside? What are the measurements and so on we do to not make there any problem? Yeah. So at the end, it's our foremost duty and the same as the high level of the quality and realism.
Exactly. So, and there's a trade-off between quality and realism on one side and reach and inclusion on the other. If you aim to reach nearly everyone, a web client is essential. But however, then you cannot have the high fidelity environments. So however, this choice with a web-based strategy and more reach demands highly optimized models, and often they sacrificing details. While this level of optimization is acceptable for many collaborative scenarios, it falls short for AI training and simulation that needs highly accurate, photorealistic digital twins. So currently there isn't a one-size-fits-all solution in that area. So in the initial phase of our project that you just saw, our emphasis was maximized on reach, to inspire a broad spectrum of users and then stakeholders at ZF to get awareness for the topic of the industrial metaverse. So, and speaking of users, brings us to other challenges, like, for example, change management.
Yeah, adopting this application, this means also that we're diving into a new and in an unfamiliar way of working, right? So at the beginning, the advantages there might not be completely clear or obvious, and not maybe immediately appreciated by everyone because they have to start a new way of working. So with the transformative shifts, there's also an element of trust that we need. I want to citate here also our higher leadership that sometimes in new things, you need to believe in it. You need to believe in it. You need to think that this technology will change something if you resist on using it, if you really try to see the benefits and not just the negative sides about this. And at the end, that's the only way how we can use the full range of its benefits. And then it's crystal clear and everyone doesn't want to change their way of working. But also to tackle these challenges in the future, we with this awesome technology, we need to implement new things and have an outlook, such, for example, NVIDIA Omniverse.
As you mentioned, Tim. So in our second phase of this partnership, we'll dive further into the Omniverse. And I think presently it's the most promising industrial metaverse platform on the market. And at the heart of Omniverse lies the Omniverse nucleus, a powerful core that utilizes the USD Universal Scene Description as its standard format. And yeah, think of it as a SharePoint for 3D content. And yeah, by converting various file formats like cat, step, and blend files and storing them in this unified format, the Omniverse nucleus breaks down barriers between different tools, platforms. And engineers working on CAD software, 3D artists using Blender, and developers in Unity or Unreal can now seamlessly collaborate. So this interoperability is essential for collaboration across departments, companies, and partners. However, there's still a little room for improvement. Currently, the Omniverse Unity connector is currently in its beta phase, and it only supports unidirectional operations, which is a little bit unfortunate because it doesn't align with our project requirements currently, because we use most of the time Unity because it offers you a very good portability also between different platforms. And so, unfortunately, we couldn't use that connector for that particular case, but we plan that for our next phase. And yet, where the Omniverse truly shines is in its hyper-realistic visualizations, for sure. NVIDIA, with all their GPU, has this ability. And leveraging technologies like NERV, I'm not sure if you heard about it, neural radiance fields, empowers photorealistic digital twins and simulations. And this is beyond aesthetics. These capabilities open doors to generating artificial training data, and this massively enhanced the training of AI. It's sometimes extremely hard and exhausting when you try to get all that data in a real factory. So you can generate millions of data in a few hours when you have artificial training data and really photorealistic twins. And with Omniverse, the potential for crafting detailed simulations in the industrial metaverse is not just promising, this is really transformative. So it paves the way for industries to mirror real world scenarios with unmatched precision and enable advanced decision making and predictive analytics. And AI is crucial for unlocking the true potential of the industrial metaverse. So, and I'm sure many of you have experienced this in a data-rich environment like ours. Ask different team members about relevant data, what you should show, and you get as many answers as there are options. So it's a maze we all have to navigate. But how can AI help? So, for example, interactive communication. Picture this. Instead of scrolling to spreadsheets, you are casually chatting with your machines. Hey, what's your oil pressure? Or how's your temperature holding up? It is as effortless as shooting a text to a colleague, or maybe have reports generated on the fly. Real-time feedback facilitating quicker decisions and troubleshooting. So, and another thing is predictive maintenance. With the massive data we have, imagine our AI predicting when our machinery might get a hiccup or need a checkup, rather than reacting. We are 2 steps ahead, saving not just costs, but also crucial production time. And then for sure, automated design goes in direction Gen AI. Gen AI doesn't stop at communication. Need a new product design or optimizing or even craft a new factory layout? Feed the AIs with some parameters and watch it craft designs with a pace we could only dream of. And next, we come to widespread adoption and standardization.
Yes. Yeah, I mean, it's becoming a big part, yeah, how we operate in our business, and more companies, they see the benefit of such environments. So just to give you an example, Siemens has announced a huge partnership with NVIDIA, or building up an industry-wide industrial metaverse, and they're spending billions in this technology. Yeah, and of course, everyone is keen to jump in, but for all of us, it needs to work well, and that's why we kind of need to have shared rules or standards. Yeah, so think like everyone is speaking the same language at the end. Yeah, for example, there's something that's called, Chris, you mentioned it earlier, this USD standard. Yeah, it's Universal Scene Description. It's like a common language for 3D visuals in the metaverse, and this is just one start, yeah, for this whole thing. So generally said, with shared standards, then every company can work together on this technology, share their developments, also bring together the machines, data, and have common insights and so on. This is our future, and this will only work if we have this common standards. Yeah, and one big thing here too, of course, Microsoft Mesh. Yeah, Microsoft is offering their Mesh platform, which is also a fundamental basis for future metaverse environments. And one future outlook is definitely that we want to use this infrastructure to bring in our developments, what we create, into this known environments. So imagine you can access it through your used to Teams clients, and you can meet in this environments using our Teams infrastructure, be in this immersive factory worlds and having access to all this data and so on. This will be definitely our big outlook to have scalability here within the whole company and the whole industry here as well. Yeah, and not just standardization, but also the immersive experience is a big part. Yeah, you all have heard about, for example, Apple Vision Pro. Probably something that will arrive the markets in the beginning of next year, and people will buy it. They will see, well, how can I use this technology for such applications, and we need to find answers for that. So, is it possible to provide those experiences on all of the different devices? Will it be what's the technology behind that? It works everywhere seamlessly and with a good performance, and we need to find answers for that. Of course, the technology is changing on a daily basis. You all know that probably. That's why you are interested in this topic, and that's why we need to always stay on the edge, be informed how is the market changing, and then react on this. So I think we have a great future outlook for this technology in general. And Chris, anything to add from your side?
I think we have the Q&A to discuss that together with our dear attendees.
So then, thank you.
Which brings us to the Q&A.
Yes, please raise your hand if you have a question. There's already 2 questions in the chat. First was from Craig. Are you pixel streaming the Omniverse app to the web?
I see. Are you pixel streaming the Omniverse app to web? No, we don't use a pixel streaming. So currently, how it's called? How's that thing called from NVIDIA? Tim, how is that called? The streaming technology from NVIDIA? Yeah, doesn't matter. But NVIDIA, they only currently supports the immersive client. So, and another downside of the pixel streaming, what we definitely have a look up, and it's on our phase 2, is for sure pixel streaming and remote rendering. But you must see it's also quite expensive from the GPU power, and the web client is much cheaper. So, but we definitely want to look at this, and this is also something maybe that also needs Omniverse a little of improvement, because we have now the highly optimized models that are also running in a web browser. But our wish would be, it's called in a 3D, it's called renditions. So we have very low renditions, but we have then other cases where we say, in this case, like we saw it in simulation, and where we need or AI training, we need very precise data. And then we want to have the high rendition models. And so we consider 2 things. It's completely the pixel streaming. And the other side, we're also checking to incorporate Azure remote rendering into it. Recently, the MetaQuest client came out, and so we can mix it. We can have a low poly environment. You go close to one of the machines and you switch to high fidelity, and then you have millions of polygons. So we check different approaches how we can use that. And one downside is also with the pixel streaming. I'm now here in a hotel in Kuala Lumpur. When I would do this, and you really need real time, and you turn around, and you have a laggy internet, I think it might have some negative health impact. So there is, as we mentioned, there's always a little bit trade-off, and you have to check which solution you want. We hope in the future to have different renditions of the factory for real-time collaboration or for really high-end for simulation and training.
Yeah,
that was
Cloud XR, yes.
Yeah.
Thanks, Greg. I didn't get the name. Yeah, Cloud XR. That's what the name I was looking for.
Okay. Can you
maybe I had a cocktail already before. Huh?
Can you see the question from Krista?
Yeah, how you have solved the challenge of working with multiple different 3D file formats that can in addition have metadata. Yeah, Christian, you mentioned it earlier, 3D data have a common format, and something that's the main challenge for our proofs. We have started simply by taking what we have and recreating the files that we need. But of course, USD is standardization. That's our future. That's where we need to go to. But Christian, you have worked from your side more on that topic. Maybe a comment from your side.
Yeah. So one of the big parts of the thing was to establish the pipeline for this kind of optimization. So we converted them and we semi-optimized them because we really want to have nice looking things and not completely auto-crunched where you have some edges broken. So we had some scripts that are removing automatically, screws and small parts that are not really necessary for what we need. So it was a semi-manual optimization process. And I think, talking effort-wise, I think it was at least half the project was trying to to get all the different formats in the right shape that we needed. And what he has mentioned with the metadata, we played around and checked also real time with Omniverse and USD. And you can have that additionally metadata. But the problem was here, as I said, we build most of the time the clients with Unity, and currently it's unidirectional. That means we can publish a scene once to the Nucleus core server, but then we cannot sync it back, and so it couldn't fulfill our requirement. But this is the final version of it. They promised that they will have this kind of a dual sync. Many other connectors have already this dual sync, so we're eagerly waiting of this. So feel free to shout out to NVIDIA or to Unity and to say, hey, we want to have this.
Yeah. And then there's a question of how do you see the future of interoperability of assets, data, and value between different organizations in a partner ecosystem? I think this is yours, Christian.
It's mine. Yeah, so I think how we imagine the collaboration, and as I said, didn't work like now with that. We have that, or ZF had this Nucleus server. And it is, when we discussed, that was really complicated. They sent us plans from factory layouts. Nobody even know how to read this. These are huge plans with different things. And the 3D designer said, what? And so it was hard for us to explain that, oh, this, and here, and this, and that. A factory layout can be quite complicated. And so our dream is, they use their tools, which they, where they're building that layouts, and they just orchestrate that thing. We opened that scene then in Unity, and from Unity, we publish our multi-user experience, but they do the factory building, and they don't explain us how we should do it. They notice they use their tools to orchestrate that thing. And this was the idea. And other things is there is also an Omniverse plugin. I also cannot remember the name, but they have a huge collection as one store where they also collect CAD data that you can use for training data, and it really would make the process much more efficient. We have another customer, for example. They do exotic case. They want to train AI, or we do that already, and use cognitive service vision AI to recognize different racks in a different racks in a rack, and it's very hard to go to the data center and try to get enough training data for this, and it's really hard. And what we're doing with them, we built in Omniverse completely virtual data centers with different light conditions, and we generate millions of training data. But actually, this is quite easy with Omniverse. But what is quite hard, try to get the CAD models from all the vendors of the different devices in the rack. This is the largest challenge we face there, and it really needs a standardization. And I think that was a very, very clever strategy from NVIDIA, because they took the problem in the core and say, we offer this USD platform. It's an open source standard from Pixar, and so that hopefully everybody will jump onto that format. So it's a bold strategy, and I think currently the best strategy that I see is coming from NVIDIA in this area.
Yeah, and I mean, also to add on that, and the big benefit here is that the big players, NVIDIA, Microsoft, and everyone, they are committed to this, and this is not just an idea. This is really a strategic approach, and I can say from perspective of CF or big enterprises, this USD thing, this is really getting more and more relevant. So our 3D artists, our 3D developers, they need to get familiar with it. They get trained. They look into how to apply it anywhere in all the projects throughout the whole organization. So this must be something actually where we at the moment need to trust in that this will find a new standard here. Yeah. No other questions.
Somebody said something. Krista also said, building a good optimization pipeline really matters until we have USD everywhere. There are two things of this. Currently, they do conversion. They do convert this to a standard format, but they don't do automatically the optimization. There are some other 3D storage management tools that do that, and there's a functionality that I actually quite miss a lot. That's exactly what I said with the LODs. Let's say Omniverse, in the current state, the nucleus, you can convert the files and have it in USD, but they are not optimized. That step is still missing, but I'm pretty sure that some of the vendors who do optimization will do that. Because NVIDIA, actually, they are not so interested in low poly, because they want to sell super high realistic things to, they produce GPUs. Maybe somebody heard about that. And so they're rather looking more in this, and they're not too interested in that low poly, but there will be eventually a plugin.
Great. Thanks. Any other questions? Anyone?
And I would say we say thank you.